AI-assisted coding is not the problem. Blind trust in AI code is the problem. In this video, we will look at 8 ways AI-generated code can turn from a productivity boost into debugging debt, security issues, and production chaos. With the growing adoption of AI coding tools, the question is not whether AI can generate code. Of course it can. The real question is, can I trust this code? And oh, how tempting it is to trust the code that is clean, confident, and even has comments. It looks like something that was written by an experienced developer who knew what he or she was doing. But this is an illusion. And many developers have already burned themselves on that. Stack Overflow's 2025 survey says that 66% of developers are frustrated by AI coding tools that are almost right but not quite. And almost right can be even more dangerous than completely wrong. Because what is almost right in a production system? The happy paths work, but the edge cases fail. The API call is valid, but the timeout behavior is wrong. The concurrent code passes tests locally, but fails in production, and so on. So the code works, the work goes on, but the bugs remain hidden. So now developers spend more time verifying the code. They read it line by line, they reproduce the problem, they check whether the generated tests actually test something meaningful. And then they ask the LLM to rewrite the code or rewrite it themselves. No wonder that another common complaint is that although AI can generate the code fast and saves time in the moment, a human gets to deal with its hallucinations later, and that takes time, a lot of time. IT Pro reports that 45% of developers say that they lose time debugging the AI-generated code. So the dark side of AI-generated code is that developers may feel faster in the moment, but the measured task time can get worse. Buggy AI-generated code is one thing, but it can also be insecure. It means that it can compile and pass all the tests, but still ship with a bunch of vulnerabilities, subtle or not. This can be weak defaults, unsafe input handling, poor authentication patterns, bad logging practices, insecure deserialization, SQL injection, and so on. Veracode's 2025 Gen AI Code Security Report says that AI-generated code introduced risky security flaws in 45% of tests, and no major language was immune. But the report also says that Java was especially bad in their tests, with 70% of flaws introduced in their test set. So, AI-generated code can be insecure, and many developers actually know about that. But things get worse when teams start treating security as a verification step after the code generation. And that is not a rare occasion. A 2026 study on AI coding assistants found that developers often move security thinking from writing the secure code to verifying the code later. In observed sessions, none of the participants specified the security requirements in the prompt, even when they knew the risks. So, the so-called productivity gain triggers a vulnerability pipeline. Generate fast, review later, miss something, patch under pressure, and then repeat. Or deal with the consequences of a data breach, depending on how lucky you are. AI does not only hallucinate code, it can also hallucinate dependencies. This quality gave rise to a new cybersecurity threat called slopsquatting. Slopsquatting is a supply chain attack when AI coding tools invent plausible package names and attackers register these names with malicious payloads. In this case, attackers don't even need to break your code. They just need to wait until your toolchain trusts the wrong name. The long-term risk of that is poisoned automation. Coding agents generate dependencies, CI installs them, scanners miss the mismatch, and the malicious package gets normalized inside the build pipeline. Once that happens, attackers may steal credentials, environmental variables, build secrets, or get access to the sources or the infrastructure. Tree Scientist 2026 Quality Transformation Report says that 60% of organizations ship untested AI-generated code. 32% do it deliberately, because executives push for speed. At the same time, GitClear's 2025 report notices a sharp rise in cloned and copy and pasted code, including 4 times more code cloning. Well, the immediate consequences are obvious. The enterprise app is full of bugs and security flaws, and production incidents multiply. The long-term risk is a code base that is full of duplicated logic, inconsistent code style, weak abstractions, missing tests, and changes nobody wants to refactor. And sooner or later, teams will have to pay the bill of slower releases, fragile refactoring, higher incident rates, missing tests, and engineering resources wasted on cleaning up the vibes. AI coding assistants can also create a privacy problem. This is because developers paste proprietary code, stack traces, logs, and sometimes secrets into tools whose data handling is not always clear for enterprise risk model. Personal AI accounts make it worse. This is because corporate code may flow through the tools and outside the corporate retention policies and audit controls. A 2025 privacy scorecard found major opacity across AI coding assistants. That includes opt-out training practices and almost a universal failure to filter secrets from prompts. Netrix also found credential storage risks in AI coding tools. That includes cases where credentials are stored as a plain JSON in predictable local paths. Also, SC World reported the Geared Guardian findings that public GitHub secret leaks rose to 34% in 2025, and that AI-assisted commits were twice as likely to leak the secrets. As a result, private source code, customer data, API keys, credentials, and what's not can leave the controlled environment. And nasty consequences of that include customer data incidents and financial losses due to intellectual property leakage. Agentic tools do not simply suggest code anymore. They can run commands, read files, install tools, edit repos, and install packages. More tasks outsourced to the AI agent. Alright, good, but also bigger blast radius if something goes wrong. And I'm talking now not only about the wiped out production database, although that is by itself is an unpleasant surprise, right? I'm also talking about the prompt injection becoming a real system action. A 2026 paper describes how hidden instructions in external artifacts can hijack the coding assistant and make it an attacker's shell. That means running unauthorized commands with the developer's privileges. The same paper reports the increase in attack success rates from 41% to 48% across the task payloads. That includes assistants searching for credentials, modifying authentication config, and exfiltrating data. Another study on AI-assisted development tools found prompt injection risks in real workloads. Tom's Hardware also reported the findings of the IDSaster research. This research revealed over 30 critical AI IDE flaws, enabling data theft and remote code execution. This is what happens when the IDE becomes both the assistant and the attack surface. JetBrains reports that 68% of developers expect employers to require AI tool proficiency. At the same time, they also worry about skill erosion and AI's negative impact on their own abilities. Forced adoption makes it worse because agentic AI becomes another distributed system to govern, debug, and maintain. As a result, teams start optimizing for AI usage instead of really relevant factors such as code reliability, maintainability, security, performance, and correctness. In the long term, organizations risk cognitive overload, inflated AI bills, weaker engineering instincts, and policies that lag behind developer behavior. Well, another consequence of that is yet to come, because organizations prefer not to hire junior developers now because AI can do their tasks. And on the other hand, juniors rely too much on AI coding tools. So there's no room for improvement or growth. And where should senior devs come from in this new reality? That is what yet awaits us. AI performs best in isolated problems and simplistic demos. But real production systems are far from that. I mean, they have inexplicit or even explicit conventions, weird build logic, undocumented constraints, and well, how can AI actually understand what is going on in this code base? It doesn't know why the code is shaped the way it is. It may include a customer-specific edge case, the migration that was half completed 3 years ago, and a method everybody is afraid of touching. And as a result, AI suggests changes that look reasonable locally, but violate the architecture, the domain rules, compatibility constraints, performance assumptions, or deployment reality. In the long term, it may cause an architectural drift with inconsistent code patterns and less shared understanding of the code base. It also weakens ownership because AI-generated changes may be integrated, but nobody fully understands how they interact with the surrounding codebase. And the larger and older the codebase is, the more dangerous the context-based automation becomes. AI-generated code is not automatically dangerous, and I do not claim that the safest way to use AI is to stop using that. No. What I'm trying to say is that AI code should be automatically untrusted. Developers must put it through the same engineering pipeline as everything else. Review, test, scan, isolate, and own the result. So, my goal is not to talk you out of using AI for coding, nor is it to give you the best practices for becoming more productive with AI. No, I want to help you set the guardrails for AI-generated code to make sure that it is secure, reliable, and maintainable before it bites you. To start, the article in the description contains several solid recommendations on how to fight the issues I mentioned in this video. And in the next videos, we will move from the dark side of coding into the engineering practices that help to keep it under control. So, subscribe to our channel so as not to miss them.